should have had some sitar music, some Indian music of some kind playing. I'd really like to go for this festival sometime where they throw this dye. Looks very surrealistic here. But we're going to go back down to earth and look at some fire sprinkler layout, information, some other design components. Sprinklers come in a variety of configurations for various applications, all kinds of sprinklers. They come in different colors and different shapes, different types for depending on what you need them for. Here we see, oh, that's not them. Those are dead mouse heads from somebody's iPhone. Okay, that must be Natalie's phone. Oh, that was from an iPad, not an iPhone. Anyway, here are some sprinklers that we could see in real life. Notice some of them are different colors. We've talked about different temperatures, etc. Here's your tip of the week. Sometimes a job seems very glamorous and has a lot of benefits and a lot of adventure and fun, but zoo janitors, that's a hazardous position. And I don't know. I don't know if this guy's alive under there. I'm imagining he's not very happy if he is. Let's look at some drawings and what should we have on the drawings? Of course, you need the walls, the doors, the stairs, and other architectural features. You need a ceiling grid, if there is one, or whatever type of ceiling there is. You need to know where the soffits are, etc. The elevations of the ceiling components. You can't always tell by looking at it if it doesn't give you some numbers. Where it goes up and down. It's common to have rooms that have more than one ceiling height in them. Lights, speakers, exit signs, other things that are attached to the ceilings. Diffusers, of course, where the air is coming from, how it's getting out, any kind of other obstructions we might have. And the sprinkler locations, that's where we come in. If it's an existing installation that's being modified, we need to show the existing sprinklers or T's if those are existing. Sometimes they're just plugged T's if it's new construction. And we should also show the fire standpipes, sprinkler risers, fire department valves, and fire extinguishers. But what should be on any drawing? Of course, we need the name of the owner, occupant, location, and for fire protection it's especially important to include the street address so the fire department knows where they're going. The north arrow, it has to be there, and it's supposed to be either up or to the right. People don't always follow that. Scale, including a graphic scale. The scale has been set in the codes to be a minimum of 1/8 inch per foot, and then we would have sometimes blow up plans a 1/4 inch or more for certain rooms to show more detail. And sometimes you would have key plans or other overall plans that might be a 1/16 of an inch or something, but you had to have everything shown at 1/8 inch minimum so that people could actually see it. These days, we're submitting for permit digitally with PDFs and DWFs, so it's not quite the same, but you need to have a graphic scale so that people can see what the scale is. You could say 1/8 inch per foot, but if it's a half size set, now it's not true, is it? So you need to say numerically and a graphic scale so you can actually see what it is. Construction and occupancy, as well as any special hazards, should be on the drawings. The building height in feet, the water main location for plumbing and fire protection concerns, and civil. Your name, of course, and your company. Use some typical symbols. Normally, for fire protection and plumbing, we show the lines lighter if it's existing and heavier if it's new. here with the existing piping and the new piping is not really showing a good contrast. There should be more contrast there. So you always have to make sure you look at the actual prints or deliverable, might be a PDF or DWF, and make sure that it's plotting the way it's supposed to so everything is clear. We need to give consideration to the ceiling types, and if there are grids or drywall ceilings, or if it's open ceilings, maybe there's some clouds. We want to align the sprinklers with the lights and diffusers, other features you might have. Avoid obstructions, of course. Here's an example of a space. For a new building, we see a ceiling grid, we see diffusers, the lights are 2x4, the ceiling grid is 2x2, and we see sometimes there are downlights that are open circles. And here the piping is showing up, the fire protection piping is showing up as a green color, not very heavy in this case. And then we see some solid dots that represent the sprinkler heads. Now sometimes they don't align with the diffusers, but sometimes if we did that, we might have had to add more sprinklers. I see a couple of cases like room 109 and 138 where the diffusers may have moved because we could have been lined up with the diffusers right next to them, but we're across from them at an angle. I don't know why. There could be different reasons. Plans change. Also, we see that our sprinkler piping is running over the diffusers. If you look along the top row of offices, 105 through 138, normally you would keep your sprinklers off of there. There might be a lot of room up above, but maybe not. And we could easily avoid that conflict. Again, maybe those diffusers all moved because they wanted to be closer to the outside wall rather than in the middle of the room. I'm not sure why they did that either. It could be any number of reasons based on airflow and so forth. You always have to coordinate. It's an example of an existing space that's being remodeled. We see the existing sprinklers with a circle. Piping is green again. Wherever we relocated the sprinkler, we showed a dot, a solid dot, and here it's colored in red. And we put an X through where the sprinkler was. And these could also have been upright sprinklers because they don't line up with the ceiling grid at all. Maybe the ceiling grid is all changed from the previous layout. I'm suspecting it was an existing developed building, just open with no ceilings, waiting for a tenant to come in. So it was what we call a base building, and then the tenant came in, and we're relocating. Notice here we see a fire standpipe, but it's actually showing two circles. So one of them might be an express standpipe, and then we have the fire standpipe, fire department valve, and a fire extinguisher cabinet. This one has an exposed cabinet mounted to the wall on the inside of the stair. There are different ways to do that too. If it was a sprinkler riser, usually you see two circles because one is the sprinkler riser and combination fire department fire standpipe, and the other one would be the drain pipe. We have a drain riser for sprinkler risers. We don't have them for fire standpipes. But if that was true, we would also see the sprinkler valving for the floor control valves. We don't see that. Basic rules for standard spray sprinklers, and we'll look at some special rules for ESFR sprinklers, etc. You can see there's a big difference between a standard spray and an existing or an extended coverage sprinkler. It covers a lot more. They're a lot bigger, and they put out a lot more water. But it's for special storage applications. Spacing for sprinklers should be normally 5 foot, 15 foot, 0 max between sprinklers, 7 foot 6 maximum from the wall. The maximum distance from the wall is half the maximum allowable distance between the sprinklers. So if you have a certain area per sprinkler that you can, say you're allowed 120 square foot per sprinkler based on your occupancy. If you go 12 foot in one direction, you go 10 foot in the other direction. 12 times 10 is 120 square feet. If you're in the direction that you're going 12 feet, that means from the end wall on each end of the room or corridor, you can be half of 12 away from the wall maximum. So you could be 6 foot from the wall, not 7 foot 6, 12 foot. And from the other side, you could be half of the maximum between the sprinklers, which is 10 feet in the other direction, so that gives you 5 feet. So each sprinkler is covering no more than 120 square feet. How does the sprinkler know what shape to go in? It doesn't. As we've looked at before, it's just spraying out. The point is we have a theoretical density that we're trying to accomplish. And that is done by following these methods. And the sprinklers overlap. So drawing a circle around each sprinkler that's got a 7 foot 6 diameter is not going to help you. If you had some strange case, you might do something like that if you had some really odd shapes. But no, that's not how it works. Sprinkler patterns and features may dictate the actual spacing. Remember, half the maximum allowable distance between sprinklers. If we have 225 square feet, that would be a met grid of 15 foot by 15 foot. Half of that would be 7 foot 6 from a wall. If we have 100 square feet allowed per sprinkler, that would be 10 foot by 10 foot. If they were equally spaced, it wouldn't have to be. It could be, and then it would be half of that, which is 5 feet from the wall. But it could also be 12 foot by 8, which is 12 times 8 is 96, or 6 feet from the wall in the 12 foot direction, or 4 foot from the wall in the 8 foot direction. And it should say that it's not combustible, what is used to say obstructed construction, and it should be 130. Maximum hazard spacing. You could still be, for ordinary hazard, you could still be 15 foot maximum between sprinklers and 7 foot 6 from a wall, but not over 130 square foot per sprinkler. So if it's 15 feet in one direction, that means 7 foot 6 in that direction, not the other direction, not both directions, because that would take you up to 15 foot by 15 foot, 225 square feet. Extra hazard and storage spacing gets a little denser, 12 foot maximum between sprinklers if your hydraulic density is greater than 0.25. Otherwise, it's 15 foot maximum. Not over 100 square feet if hydraulic density is greater than 0.25. Not over 130 square feet if hydraulic density is less than 0.25. Some other rules: minimum distance between sprinklers is 6 feet, because if one goes off first, it will can cool off the other sprinkler and keep it from going off as quickly as it would have normally. Sprinklers must be at least more than 3 inches from the wall. Well, there are sidewall sprinklers, but because of the diameter of the sprinkler, you have to be at least 3 inches, but it should be 6 inches at least from the walls. Maximum system size is 52,000 square feet for light hazard or ordinary hazard, and 40,000 square feet for extra hazard and storage facilities. The deflector on the sprinkler is often used as indicating where the minimum and maximum dimensions are from the construction. So unobstructed construction, you're a minimum of 1 inch or a maximum of 12 inches. Chicago, just to be a little different, maximum distance between the deflector and the unobstructed construction is 8 inches. For obstructed construction, it's between 1 inches and 6 inches below the structural member, but not over 22 inches below the deck. It sounds like we should have had a detail for that, but in the materials that I gave you, you'll find these. And if you look at NFPA 13, you'll find diagrams of these things. Extended coverage sprinklers are different. Can't use them in Chicago, but spacing limited to listing of the specific sprinkler with 400 square foot per max. 400 square foot per head maximum. What that means is the maximum listing is what the manufacturer received test results for that specific sprinkler and that specific spacing. That's the maximum. City of Chicago only allows use of extended coverage sidewalls for light hazard occupancies. Extended coverage pendants are not allowed in Chicago. Where do we install sprinklers? Well, all spaces within a building except Chicago is different, so let's look at those first. Electrical rooms over 600 volts, main switchgear rooms, ComEd vaults, transformer rooms, emergency generator rooms, elevator machine rooms, freezers under 200 square feet, closets under 20 square feet, and residential occupancies. Per NFPA 13, it's not required in non-combustible stair shafts except at the top and the bottom. Bathrooms in dwelling units under 55 square feet. Closets under 24 square feet in hotels and motels. Portable wardrobe cabinets. Most electrical rooms, but that's according to the authority having jurisdiction. You know, electrical equipment doesn't like water. Water and electricity don't mix very well, so you always have to balance that out and consult with the authority having jurisdiction. A lot of times the fire prevention authorities want them everywhere, and the electrical people don't want them anywhere as close to any electrical equipment. Let's look at design densities a little bit for light hazard, and then we have ordinary hazard group 1, ordinary hazard group 2, extra hazard group 1, extra hazard group 2. For light hazard, for the rest of the world, it's 0.10 GPM per over the most remote 1,500 square feet. Chicago, it's 0.10 or 0.12 over the most remote 1,500 square feet. Ordinary hazard is 0.15 over 1,500 square feet, but in Chicago it's 0.20 over 2,000 square feet if 14 foot or under in height. Ordinary group 2 is 0.20 GPM per square foot over the most remote 1,500 square feet, except in Chicago it's 0.25 over 2,500 if over 14 feet. An example of ordinary hazard group 2 is mercantile. That means that shopping malls, well, they might not, so you have to make sure that you cover that. And mercantile spaces. Extra hazard, and as we said before, it doesn't matter if they're selling alcohol, which is flammable, and the whole place is basically full of flammable liquids, or if they're selling kites, which might be flammable, or ceramics, which are not so flammable. Doesn't matter. Extra hazard group 1 would be 0.30 GPM per square foot over the most remote 2,500 square feet. But in Chicago, again, it's a little bit different, a little denser, 0.30 over the most remote 3,000 square feet. And group 2 is 0.40 over 2,500, and in Chicago it's just the same, 0.30 over 3,000. When you get up to that point, you have to look at the authority having jurisdiction to make sure that whatever is pushing you over that extra hazard limit is covered, and that they feel comfortable with the numbers that you're using. If you don't use their numbers, you're going to have issues. Here's some examples of schedules that we put on the drawings. This is a sprinkler system schedule. You'll notice on the left we have the type of space, then we have the hazard class, the occupancy class, and we have the densities, the sprinkler densities. And so this is the hydraulic design criteria with the density over the most remote square feet area, and then what type of system. These are all wet systems. No design adjustments are required for them. The ceiling heights, notice we have less than 14 feet and greater than 14 feet listed. And then we have the maximum area per sprinkler listed, and the hose demand that would be calculated into the hydraulic calculations. This should be on your drawings, every project. You also should have something like this. This is a sprinkler schedule. So this has the manufacturers of the sprinklers and what type they are, model number, the coverage, where they are, and what the finish is. Remember, finishes always have to be approved by the architect. Everything for fire protection has to be UL FM approved unless there's some other indication for some reason. The sprinkler system piping and hanger schedule is something that we like to include. So this is this tells you the pipe, what kind of pipe it would be for a certain size. Like for the smaller pipes it's schedule 40, for larger pipes it could be schedule 10 maybe, and then what type of hanger that needs, the minimum rod size, the attachment method for the hangers, and the maximum spacing. And there are a few notes there. There are other density rules. There's no reduction in design areas allowed in Chicago. The room design method is not allowed in Chicago. So we won't talk about it too much, but we'll talk about it a little. We add 30% to design area for sloped ceilings, and we add 30% to design area for dry and double interlock pre-action systems. It's accounting for the fact that there's a delay in between when the sprinkler fuses and the water comes out. Just a note about the room design method. The water supply for sprinklers only must be determined either from the area density curves provided in NFPA or based upon the room design method in accordance with NFPA 1311.2.3.3. Again, room design method not allowed in Chicago, but we wanted to mention it. We don't only work in Chicago. Sprinkler layout always has to consider all the architectural features. In commercial office spaces, it's common to have ceiling tiles, acoustical ceiling tiles, hung from the slab that are 24 inches by 24 inches, and sometimes 24 by 48. But normally 24 by 24, and then the light fixture would be 24 by 48, and diffusers would normally be 24 by 24. Sometimes we have 12 by 12 ceiling tiles, which would normally be a concealed spline. With the 24 by 24 ceiling tiles, you'll see a strip between each tile that actually supports the tiles. They're lay-in tiles, and they sit in that framework. You can push them up out of there. A concealed spline, they interlock together, and you do not see what's holding them together. Some buildings have 20 by 60 tiles forming a 5-foot by 5-foot grid. This can align with the typical Mies van der Rohe type 60-inch mullion configuration. You see this in a lot of steel buildings, 60-inch window mullions. and the ceiling tiles line up the same in every section because they're 20 inches each, so 3 times 20 60, so 60 by 60. But the lights are usually 20 by 48, and then you would have a 6-inch strip on each end of the light. So you could put sprinklers there on the end, or you could put them in the center of the 20 by 20 sections. See that a lot downtown in high-rise office buildings. Some other architectural features might be drywall soffits. They were very common, and soffits will usually be at different heights than the ceiling tiles, but not always. Sometimes you'll have an acoustical ceiling tile, and then you'll have some drywall at the same elevation, but it's normally going to be higher or lower. Any number of variations are possible. Here's a section showing a ceiling obstruction. We have it could be a beam, it could be a duct, it could be just a soffit for some reason, architectural reasons, and the how far we are from the beam and how far we are above the bottom of the obstruction. Uh, there's a lot of dynamics involved here. So in NFPA we have charts that show us the distances we can be, how far the sprinkler has to be away from the wall to get under it. If the sprinkler was right next to the wall, obviously it's going to be more of an obstruction than if it's 7 feet away from it and it's only 12 inches deep. We can easily spray under it. Plaster ceilings can be even more problematic because there's a variety of complexities in their construction, and sometimes there's a metal lath construction. If it's an old ceiling, you might not be able to get sprinklers in there. It could be these arched ceramic tiles that could be 9 inches deep, and while there are holes, channels through them, they have a structural function, and you would probably have to have exposed sprinklers and piping if the building was of a historic nature and you couldn't damage the tiles. We should consider alternatives such as sidewall sprinklers also, or maybe some soffits, or sometimes the soffits can be prefabbed boxes, box type devices that travel along the corner of the room at the ceiling to conceal that sprinkler, or it could be in the middle of the room and it's just like a rectangular shaped box running the length of the room attached to the ceiling with sprinklers sticking out of it and the pipe concealed. You know, this drawing makes it look kind of simple. It's not really this easy. You need a few inches above, and depending on the type of ceiling that you have, you could have you might not be able to put anything in there. Fahrenheit 451. Remember that one? What is that? Flash point of paper. Right. Here's some typical details for some projects. Take some time to review them. They'll help you to understand how these things work and the type of thing that's expected to produce contract documents, the things that you and I do all the time. We'll go through them pretty quickly, but this is a typical soffit detail that we made for an existing building that was not sprinklered. We were running a sprinkler pipe in the corner of the corridor, and they wanted them to be concealed, so they built a soffit, and there are certain limitations to the size of the soffit, but it's very hard to get all this stuff in there. We wanted to have a sprinkler loop, a sidewall sprinkler that's concealed, and we wanted to have the ability to tap into that to run sprinklers into other rooms later. Right now, it was only partially sprinklered. This is a sprinkler floor control valve assembly. You can see the tamper switch on the OSMY gate valve. You can see the water flow switch, a pressure gauge, and inspector's test connection. This goes back to we'll go back to the drain riser. This goes to the fire standpipe sprinkler riser, and the sprinklers are connected to the other side. Here's a sprinkler arm over bend detail. You see the branch line in the center, and then the pipe goes up, has an elbow, goes over, another elbow, comes down. This traps sediment in the piping, not in the sprinkler, and it also gives you some flexibility for adjusting the location a little bit of the sprinkler by rotating the fittings up above. This is a concealed sprinkler detail. You know, they won't all be exactly like this, but you can see the cover plate here on the ceiling. It's showing you know, two variations, and you know, to show the range, and you know, take a look at it, you can get some ideas. This is a Siamese connection detail. In this case, the check valve apparently is in the basement. Notice we have an automatic drip, and we have this is a check valve that has a should have a ball drip, we call it. And if there's any pipe, since this is outside, the fire department Siamese hose valve is outside, and the other part is inside. If this is used in the winter, then the piping going down to the check valve could have water in it. You don't want that to freeze, so it has that ball drip valve to let the water out and not break the sprinklers. Here's kind of an isometric view of some sidewalk Siamese connections. Same kind of thing, except one is a Siamese fire standpipe connection. It's the fire department connection that the fire department is pumping water in, and the other one is a freestanding fire pump test connection to test the fire pump, so it's pumping out. This is a fire pump detail. You can see the incoming service is actually installed by the plumbing contractor. Normally the double check backflow preventer is installed by the plumbing contractor, but it might be purchased by the fire protection. That's something that could be worked out on different projects. And then we have the fire pump. The jockey pump isn't really underneath. It was just shown that way so it could be seen. And you can see some other details there. Here's a dry pipe valve assembly detail. Shows a lot of detail. We've talked about these, and take some time to look at it. This is important too. It's a fire stop penetration for a pipe going through a concrete wall. There, you know, we don't want the fire to be able to get through around the pipe. We've included a lot of things here about building construction. Some notes that I think you should take a look at, or some additional information, testing, standards, etc. And so you can go through, and you can go through them more slowly, and you know, see what you know and what you don't know. Here's some good things for you to look at. I didn't give you the answers to everything. I wanted you to think about it a little bit. We've spoken about a lot of these. Remember, for pipe sizing for pumps, it's 250 GPM for the first standpipe, 250 for each additional standpipe. Maximum pump size per NFPA right now is 1250 GPM. Local codes may vary. 6-inch fire service is good for up to 750 GPM. 8-inch fire service for over 750 GPM. May need to increase the combined service if domestic load is too large. In Chicago, you add 2 inches. So if we need a fire pump, no matter how small the system is, we need at least a 6-inch service for fire protection. If the water service is larger than 2 inches for domestic, now we have to increase the size of the 6-inch by 2 inches, and that'll give us an 8-inch. So minimum size combined domestic fire service would be 8 inch. It could be 6 if your 2 inches are smaller on the domestic side, but that doesn't happen a lot on the commercial buildings. This is an interesting slide. Oops, I thought that might scare somebody, and I thought that was cool. That's it. Thank you. Good night. Thanks for coming in. You can go to sleep now. Thank you. Okay, examples of fire pump room. Uh, Fire pump's laid out here. I don't know why I didn't fix the colors. Fire pump is kind of yellowish color, and some of the stuff is green. That's one example. Notice the pump controllers on the north wall. You need 3 foot clear in front of those, and that means you need a lot of space. Here's a schematic of that pump room detail, and it shows all the components. Here's a comparison between a horizontal split case pump. Remember, that's the most common type of fire pump that we see, but the vertical inline pump is very popular these days, and it takes up 30% less space, and it has a lot of advantages. And it's going to be, it might cost more for the pump, but the installation is easier and cheaper. So do you have any questions? I can't hear you. Okay, so home fire sprinklers save lives. I'd like you to take a look at this. It's kind of hard to see here, but it's www.firesprinklersma.org. Just take a look at it, and remember, the one of the most important parts of a fire protection system are the firemen, and that we don't really deal with that in the building trades directly, although everything we do, or much of what we do, is centered around them. We don't really deal with them on our typical building, but we want to give respect and be cognizant of them. Without them, our jobs would be a lot harder, and the buildings would still burn down without the firemen. So sorry they had to die. Other than that, life is good. Goodbye. Keep your eyes open for exams coming up. Is it time for a break? Well, it could be, because you're doing this one at home. So sorry it took so long to get it to you. And watch out for those wild bunnies. I heard they hang out in the dorm rooms. Thank you. Now, I posted a lot of material this week. Go look at it and be ready for the exam coming up. Thank you.